Good morning students, welcome to our next lecture of DSA and today's topic is graph. Graph is the fifth unit of our subject DSA. In DSA, what we are studying about the different data structures. Data structures means how we can store our data in different forms, that is in a proper format and an improper format. That means in data structure we have studied in earlier units that data can be stored in two ways. First one is linear and second is non-linear. So we are storing data in two ways, linear and non-linear, and these two ways are known as the types of data structures that we are using for storing our data. So the examples of linear data structures are stack, queue and linked list. The basic introductions, operations and various types of linear data structures we have studied in our earlier lectures. Now we are studying non-linear data structure. Examples of non-linear data structures are tree and graph. So today we are studying graphs, and graphs are nothing but non-linear data structures. Non-linear data structures means data which is not stored in a proper format. Proper format can be described as either in increasing form or in decreasing form. So the data that is not stored in either increasing form or decreasing form is known as non-linear data structure. So today we are studying about graphs. Graphs are non-linear data structures, and graphs are mainly used for finding shortest paths, shortest routes, project planning, etc. Project planning here means the kind of projects like highway projects, railway projects, in which we have to take the shortest path to reach from one point to another point, and the starting point is known as the source and the ending point to which we want to reach is known as the destination. So graphs are mainly used for finding shortest routes and project planning. Now this was the basic introduction of graph. But the main thing that we should know is the definition of graph. How we can define a graph. A graph is defined using the equation G is equals to VE, where capital G denotes the graph, V denotes the set of vertices and E denotes the set of edges. Vertices are these A, B and C. These are the set of vertices, and these E1, E3, E2, these are the set of edges. So this is the basic definition of graph, where we are representing graph with capital G, V set of vertices, and E represents set of edges. So this is the basic definition of graph. G, capital G is equals to VE. That means graph is equals to a combination of set of vertices and the set of edges. Now the thing that we should always keep in mind is that vertices are also known as the nodes. Vertices are also known as the nodes, and the edges are also known as the arcs. Okay, so here we can say that node or vertices are A, B and C. Edges or arcs are E1, E2, E3. So nodes, vertices are also known as nodes and edges are also known as arcs. Now let's see how we can display, how we can denote the graph. Here we have vertices is equals to A, B and C. These are our three vertices in this given graph. Edges are E1, E2 and E3. Now let's see the edges. Edge E1 is connecting which two vertices? A and B. Edge 1 is connecting the two nodes A and B. So we can write here A, B or BA. So edge 1 E1 is connecting our two nodes A to B. Since we are not given any direction of the edge, that we are traveling from either A to B or B to A, so we can represent this edge in two ways, either from A to B or from B to A. Second edge is connecting, E2 is connecting nodes AC or CA similarly, and the edge E3 is connecting the nodes BC or CA. This thing we should always keep in mind, that for connecting the nodes through the edges, when we are given a proper direction, then we will represent the nodes in that direction. But if we are not given any proper direction, then we can represent the edge which is connecting the nodes in both ways, either A to B or B to A. Similarly, E2 is connecting nodes A and C from either A to C or C to A. Similarly, edge E3 is connecting the nodes B and C. This can be connected in two ways. First one is either from B to C and the second one is either C to B. So this was the basic representation of graph. Now we will study about the graph terminology. The basic terminology that we will be using throughout this unit should be understood first, so that we should not face any problem regarding the terminology. So first terminology of graph is directed edge. Directed edge means, as the name suggests, suppose that we have a new graph A, B, C and D. These are our four vertices. Now we will connect these four vertices through the edges. Okay, so now this becomes our graph. First terminology is directed edge. Directed edge means, as the name suggests, directed. Directed means we are given a proper direction. Direction of what? We are given a proper direction of edge. Direction of edge denotes the flow of data, the path that we are covering from source to destination. So directed edge means we are given a proper direction of the edge that represents data is traveling from one node to another node. So when any node is connected with a proper direction, direction is represented with the arrow. So here edge E1 is the directed edge, all other edges are undirected edge. So because the edge that is connecting the node A to B, here we can understand by the direction of the edge that A is connected to B through the edge E1. So this is the meaning of directed edge, that when we have a proper direction of edge from one node to another node is known as the directed edge. Second terminology is undirected edge. Undirected edge means the edges which do not have any direction are known as undirected edge. So this can be understood using this example. Undirected edge means the edge with no direction. So the edges E2, E3, E4 and E5 are known as undirected edges because these edges do not have any direction. So this was undirected edge. Now the third terminology is directed graph. Directed graph means, till now we have studied directed edge and undirected edge. Now directed graph. Directed graph is nothing but a graph with all the edges in proper direction. Directed graph means graph in which all the edges are directed. So directed graph is the graph in which all the edges are directed. This graph is not the example of directed graph. This graph is also not the example of directed graph, but if we give direction to all the edges, now all the edges have proper direction. Now this graph becomes the directed graph. Okay. Now the next terminology comes is undirected graph. Undirected graph is a graph with all the edges with no direction. Okay. So undirected graph is the opposite of directed graph. So this is the directed graph in which we have all the edges with a proper direction. But in undirected graph, this is the example of undirected graph. In undirected graph, we don't have edges with proper direction. Okay. Now have you understand the basic difference between directed graph and undirected graph? Now next terminology comes as mixed graph. As the name suggests, mixed graph is a kind of graph in which some edges are directed and some edges are undirected. So the graph, I repeat, so the graph in which some of the edges are directed and some of the edges are undirected is known as a mixed graph. Now the next terminology comes as multigraph. What is the meaning of multigraph? Multigraph is a kind of graph in which we have multiple edges between two nodes. Okay. Try to understand this. Multigraph means any graph in which we have multiple edges between two nodes or vertices. Now let's take this example. Suppose this is our graph. To make this graph as multi graph, what we will do, we will connect another edge from B to A, and this edge is named as E6. So for connecting the nodes A and B, we have two edges. So this becomes our multi graph. Now the next terminology comes as simple graph. Simple graph means a graph with a set of vertices and edges connecting those vertices. So this is the basic example, simplest example of simple graph. This example, by seeing this example, we can understand the concept of simple graph. Any graph with a set of vertices and those set of vertices connected by a set of edges. So this is the example of simple graph. Now next terminology comes is null graph. As the name suggests, null graph. Null graph is a graph in which we have a set of edges but not the set of vertices. We have a set of edges but not the set of vertices. That kind of graph is known as null graph. For example, the null graph of this graph can be created as A, B, C and D. These are the four vertices. So this becomes our null graph because we don't have any of the edges joining these vertices. This null graph is also known as skeleton of graph. So we can call null graph as skeleton of graph. Null graph is nothing but the set of vertices and these vertices are not connected by any of the edges. Now the next terminology comes is isolated vertex. Isolated vertex means, suppose that this is our graph, this is our graph, this graph is an example of a simple graph. Now we are talking about isolated vertex. Isolated vertex means, suppose that we remove this edge from A to B and next edge from B to C. After removing the edge from A to B and B to C, the vertex, this vertex B becomes isolated. Because now this vertex, this node B is not connected to any of other nodes given in the graph. So this node, this vertex of this given graph becomes isolated. That means it goes out of the graph and is not connected to any of the nodes. So this becomes isolated vertex. Okay, understood? Now the next terminology comes is path. The meaning of path. Path is nothing but a node from which we are starting our journey and the node which we have to reach is at the end, and the path and the way that we are taking to start from our starting node and come to an ending node is known as the path. Okay, so taking this example, example of the graph, suppose that A is our starting node and C is our ending node. So we have two ways. Two ways means we can travel from node, that is node A, that is our starting node, to node C, that is our ending node. So we have two ways, two paths from A to C. We can reach from A to C in two ways. First way is directly A to C and the second way is A to D and then D to C. So these are the paths. paths, these are the paths. Path is nothing but the route, but the way that we are taking from a node that is known as the starting node to reach the node which is known as the destination node or the ending node of our graph. So this is the meaning of path. Now the next terminology comes is source. Source means, source is also known as the starting node or vertex. Sink is destination node or vertex. So source and sink are the nodes or vertices which are the starting node and the destination node. Starting node means, suppose that we have, let's take this example of the graph. Suppose that we have this graph and here our starting node is A, starting node, or we can say that source node, from which we will start traveling our graph, and C is our destination node or sink node. So for traveling from starting node or source node A to destination or sink node C, we follow a path, as I have already described the meaning of path. So the starting node that we will take to travel our graph and the destination node means the sink node, the ending node to which we have to travel our graph is known as the sink node. So this was the basic introduction of graphs. In this basic introduction we have discussed the meaning of graphs, how graphs are used in our daily routines, in our daily projects, and then we discussed about the definition of graph, which is given by G is equals to VE. After the definition of graph, we have discussed different terminologies that we will discuss, we will frequently used in our further topics. So that's why I discussed these 12 terminologies, so that while discussing them in our next lectures, you won't face any problem. So we have discussed these 12 terminology of the graph. These 12 terminologies will be frequently used in our next lectures. I hope you all have understood this basic lecture on the graphs. If any problem,